Hello folks, welcome to a little corner of the internet called Marshable Math. Today we're going to be discussing functions, so get yourself a piece of paper and a pencil, maybe a calculator handy, and let's jump right in. Now, a function is a relationship in which there is only one output for each input. It's very specific in the wording, so make sure that you get that right. A relationship in which there is only one output for each input. Now, most equations that you're familiar with are already functions. So take, for example, this equation here. Y is equal to 3x minus 2. We say here that since the equation solved for y, that y depends upon what we do here for x. So we would call y the dependent variable. We would call x the independent variable. The x then is our input. It's what we put into the equation, and the y is the result. That's what we get out. So x would be the input, y would be the output. And let's take a look at what we get here. If I just do a table of values, I put in values for x and see what I get for y. If I put in 1 for x, what is y? Well, 3 times 1 is 3 minus 2. That gives me an output of 1. Follow? You've done stuff like this before? So if I put in 2, 3 times 2 is 6, minus 2 is 4. Input of 2, output of 4. If I put in negative 1, you'll see that I should get negative 5. So notice that I'm getting outputs for inputs, but if I put in a duplicate input, if I put, say, hey, what happens if I put in 2 back into the equation again? 3 times 2 is 6 minus 2. Do I not get out the same thing that I had gotten previously? If the answer to that is yes, then what you've got is a function. If the answer to that is no, if you have a duplicate input that does not give you an identical output, then you know that it's not a function. Sometimes we call these things domain and the range. The domain then would be the allowable inputs that you have for a function. The range would be then the allowable outputs. But it means the same thing. This is the input and this is the output. It's kind of a simple way of thinking like a mathematical machine. You put something into the machine and it does something to it, and then you get a result back out. One of the first questions that you're going to be asked is how to tell if something is a function or not. And we've already done one of those here. But the simplest way on a table of values is simply to look for a duplicate input. If you don't have a duplicate input, you go ahead and assume, well, hey, it's got to be a function. Okay? But if you do have a duplicate input, you must have a duplicate output. Otherwise, it's not a function. Now remember, if we're going to do this on a graph, these are ordered pairs. So if I come over here and I plot these points, then I get something that looks like this. This is 1, 1. That's that location right there. 2 gives me 4. 1, 2, 3, 4 gives me this location here. Negative 1, negative 5, negative 1, 1, 2, 3, 4. I'm off the graph there. Too bad. All right, so I get these different points. If you look at a graph and you're trying to figure out if something is a function, what do you look for? Well, let's say, for example, that when I put 2 in, somehow I had some kind of a hiccup and I got something other than 4. Let's say that I got 3. We would say, oh, on a table of values, we know that's not a function, but what does that look like over here? If I plot that point 2, 3, I get this idea right here. Do you see that I've got 2 y values here stacked on top of each other? In other words, for a single x value, which is 2, I have 2 different y values, a 3 and a 4. If you ever see points plotted, or maybe even a graph, where you've got more than one point for a particular x, in other words, if they stack up on top of each other, you know that that is not a function. Oftentimes we use what's called a vertical line test for this. So if we're looking at a graph, the question is, gee, can we take a vertical line, illustrated here by this straight edge, can we take a vertical line and can we move that anywhere on the graph and have it touch the graph at more than one location? If the answer is yes, then we say that that fails the vertical line test. So if I move this here from left to right, we see that, oops, right there, it touches the graph twice, so it fails the vertical line test. Sometimes, though, you don't have points. Sometimes you've got an actual, kind of a flowy kind of a graph that looks like this. Something like that. Okay, is that a function? Well, we're going to just take our vertical line test and do it here. So if I have the vertical line, can I move it anywhere on the graph and have it touch more than once? Well, as you can see, it touches here, and then as I move it forward, it continues to kind of touch the graph. It only touches once. So that would be a function. What would it look like if it wasn't a function? What if I did something like comes up and then it comes back around like this and then forward? If I take my vertical line now and move it from left to right or right to left, doesn't really matter. It touches at one point here, but you'll notice when I get to this location here, it touches in 1, 2, 3 points. That fails the vertical line test. Now remember what it means. There's only one output for each input. So we could say only one y value maybe for each x value. But notice right here, for an x value of -1, I've got a y value right there, maybe at 0, and then a y value here, which is at 1, 2, 3, 4. I've got a y value of 4, and I got another one way up here. Okay, so I've got more than one. That would be a failure of the vertical line test, not a function. Let's see here. One of the ways I like to think about functions is like a vending machine. And maybe this analogy will help you out a little bit. You go to a vending machine, you put your money in, you push a button, and you expect to get something out in return, right? So say, for example, you press the button and you got a Dr. Pepper, because everybody knows that's all anybody really would ever want to get out of a vending machine is a Dr. Pepper. If there's no Dr. Pepper, you have to settle for something like Coke or something like that, because Dr. Pepper is the best. But when you press the button for the Dr. Pepper, you expect out to get a Dr. Pepper. What if there weren't any labels on the button? Well, you still would expect that when you pressed a button and out comes a Dr. Pepper, the assumption is every time you press that button, you're going to get out the same thing, right? So you run it through with a group of friends and you all put your money in, and the first guy, he gets his Dr. Pepper. The second guy presses the button, he gets out his Dr. Pepper. The third guy presses his button and he gets a cranberry Sprite. What? What's up with that? Well, something's wrong, right? Every time you press the button, you should be getting the same thing out. If not, something's wrong with the machine, right? So the same thing with a function. When you put something in, you should get something out. When you put the same thing in, you should get the same thing back out. So hopefully that helps. Now, one of the things that's interesting about functions is a new way of writing equations. That equation that we had in the very, very beginning, y is equal to 3x minus 2. There's a new way of writing this, and it's efficient. It's kind of confusing at first,